You put it on my notes.
I'm gonna ask you to talk me through it. I don't want you to just
I
Yes, you did. What do you do with the percent?
honestly don't know.
Okay, when you have to work with the percent anywhere in math.
That's what that's what.
Okay, so you gotta change your percent to a decimal.
Yes.
And did I give you a math? Did I give you a math or did I 80%?
Yes.
So could you take 0.8 and multiply by 127?
Yes.
Could you take,
And then divide it by.
no? Can you take 0.17 and multiply by 126? Can you take 0.03 and multiply by 128? Okay, does that give you the amount that each one of those makes from that percent,
Yes.
correct? Then if you add them up? Oh, yes, you do. Okay, I wanted you to talk me through it. I didn't want you, no, I wanted you to talk through it. That was very important to me. Trey, it's gonna go. Oh! I came all the way to Paul. Paul, can you go pick up the script and hand it to Trey? What do you want? I have skills.
I'm sorry.
We're
supposed to take care of it. I'm pretty much like parent.
Come on, Paul, let's go. How many of you have had enough time to find the answer to that particular question? How many of you say you had enough time? Just, I just want you to do the first one. Did everybody do the first one? Okay, I ended up, the work I did with that first one turned out to be 126.86, and then what do you have to put on as units for that? What is it? AMUs, very good. All right. Oops, here's a picture of one. All right. I'm not going to do the rest of these with you. If you need more practice, great. If you think you understand this, you need to continue doing these. This is up to you now. Now, the next one I would like now to look at is, now you all should have this one. Is that correct? Okay, in a minute, I'm going to ask you to draw a picture of some isotopes. Before we do that, I'm going to model an example for you. And the example I'm going to do is carbon 12 versus carbon 13. All right, so how many isotopes of carbon do I have? How many isotopes of carbon do I have? I have 2 isotopes of carbon. If I look at the element carbon, and I'm looking at this was carbon with a mass of 12, and this one is carbon with a mass of 13. But in both cases, how many protons do both carbons have? 6. So now if I was going to make a model of this, and I'm going to be a little extravagant here, and I was going to draw the nucleus, how many protons would I have to have inside that nucleus?
How do we know there's 6 protons?
Because it's element carbon. So I go to the periodic table, Paul, and what is that blue number up there on? And that's where I got it from. Because that's called the atomic what up there?
Number.
Yes. Okay, so I'm going to put in 6 protons. I don't care how you want to do it. I just put in 6 protons. Is everybody correct on that? Now, if it's got 6 protons and it has a mass of 12, how many neutrons does it have? It's got 6 neutrons. So then what else do I have to put inside this nucleus? I got to put in 6 neutrons. All right. Now, in addition to that, it also has what? I can hear you guys saying it. It's got 6 electrons. Now, the electrons, are they inside the nucleus or are they outside the nucleus?
How do we know there's 6 neutrons?
Because the mass is 12. In order to get the mass, remember it's protons plus neutrons equals mass.
That was dumb.
Okay? Now, There's a couple ways I'm gonna allow you to do the electrons. Is everybody okay with that? Because we haven't really studied electrons yet, is that correct? Now, some of you who took physical science would know that you could do one and put 2 electrons here, and you could do another one and put 4 electrons here. And some of you may know that because you took physical science, is that correct? Some of you did not take physical science, so you don't know that. So it just depends on your background. So what's another way you could do it? You could actually do this, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. And could we just do some sort of like shaded region on the outside of this? Is that correct? And could we just put 6 little electrons floating around on the outside of it somewhere? Would that also be an acceptable drawing for that isotope? I don't care which way you do it, okay? But we should know that there, and that all I'm doing is making some random cloud, and in that cloud there is 6 electrons. Because guess what we study in the next chapter? We'll study the cloud and the electrons, and you'll know more what to do. So I'm not going to be picky at that right now. Now, that's only the first isotope. Which one do you guys like better? Do you like this one or this one? Because I got to erase one. Oh my goodness, we're 50-50. Okay, thank you. All right, then guess what we'll do? We'll just put carbon-13 over here. So all of a sudden, I have to do carbon-13. How's my model going to change? There's like one change in the entire model from one to the next. What is it?
I was so worried.
The number of neutrons. So I still have my 6 protons, but instead of having 6 neutrons now, what do I have? I have 7 neutrons. We said we like both, I don't know. So if you want the cloud version, you do this, and still, how many dots are out here in the cloud? 6. If you like the other version, then you would do a circle and put 2 electrons, and do another circle and put 4 electrons. I don't care which way you do it. Whichever model makes you happy makes me happy. All right, so basically what we're doing is we're making a model of our isotope, because one of the things we need to be able to do in addition to finding the protons, neutrons, and electrons, should we have a concept of what it might sort of look like on a large scale. Yeah.
Now, this might be a dumb question, but does it matter how many electrons go on each ring?
There is a difference, yeah. The first ring maxes out on exactly how many electrons. There is a truth to that, since you're asking. You can only hold 2.
Okay.
The next one actually can only hold a maximum of 8. The third one can hold up to 18. The fourth one can hold up to 32. And it keeps growing, okay? But that's how that works. At this point, I don't expect you to know that. By the end of the next chapter, oh yeah, you'll know that. Okay, but we don't have to know that for this chapter. All right, so that's next chapter. So right now, I just want to know that protons and neutrons are in the nucleus and the electrons are outside of it. As long as you know that, I'm happy with you. Is everybody okay with that? Now, flip your paper over, and the very last question asks you to draw me a model of lithium-6 and lithium-7. I actually gave you something a lot easier than carbon, okay? Because these masses are only 6 and 7, so you have a lot fewer protons and neutrons to deal with. Could you guys draw me a model on your own of lithium? That's what I'd like you to do right now. So take that very last, it's the very last question on the isotope page. And I would like you to draw me 2 pictures, one of lithium-6 and one of lithium-7. It is, it's this one, and it's this question right here. So what I just did with carbon, I would like you to do with lithium. Hey, Paul, can I have your binder real quick? Which one's your chemistry binder? This one? Yeah. All right, I'm gonna make sure we have all your papers put up. How do you guys are looking on this?
No, I just have it. She gave it to me. No, yesterday or a couple days ago.
That's all the stuff I'm passing out today. This is just review, there's nothing to do yet. So you can go over all of that. Yeah. Okay. You want a note on it, or you want me to?
I'm just gonna paper clip
Okay,
it,
I'll
and then
move it.
I'm gonna put a post-it note on it, and then you can write what needs to be.
Very good.
Which model are we supposed to use for our diagram?
It doesn't matter, well, it has to be a Bohr's,
How do we know, like?
because it's only one with protons and neutrons in it. None of the other ones had neutrons in it. Now, you could do the electron cloud model, but the only problem with the electron cloud model is it's so tiny, can you actually see the protons and neutrons in that one? So Bohr's your best bet for that
So
one.
like we do 3 orbitals,
No, it actually only need 2.
up there at 3.
But you could have 3, but we only need 2, because there's only 3 electrons.
That's all the handouts today, right?
Yeah, plus the handouts from today, but the handouts from today are all optional practice.
It's how you determine when the electrons go in the orbitals.
I told you you don't need to know that till next chapter, just how many electrons do I want on the outside.
3
As long as you put 3, I'm happy. Because guess what the next chapter's on?
orbitals.
Yes, that's what the next chapter's on. Okay, I did the electron cloud when I did this particular one. So my 2 versions of lithium-6 and lithium-7 was 3 protons, 3 protons, 3 neutrons, 4 neutrons, 3 electrons, 3 electrons. And I did the cloud version for mine. If you did the orbital version, perfect. You'd have 2 in 1. Okay? I mean, in other words, you'd have 3 on one side and 3 on the other. And how you do that, I'm not even picking on the electrons. Is everybody okay with that?
I'm just making sure, I did copy it, you understood that 3 dots.
I did 3 E's instead. You see my 3 E minuses?
It didn't matter what it was.
I did dots in one, dashes in another, and did E's up here. It's just a model. Does that make sense? As long as your model is count accurate and in the right location, I'm a happy lady. Does that help you out, Owen? Okay. So I'm not stressing on your picture being identical to everybody else's picture, other than right number of protons, right number of neutrons, right number of electrons, protons, neutrons, and electrons are where they're supposed to be, either in the nucleus or outside of it. We just never really made a model, and I didn't want to surprise you because one of the things we do a lot in chemistry, which you guys agree, I make you draw pictures a lot. I just wanted to make sure you understood how to draw a picture, all right? So I just want to make sure you had that. I just spent 10 minutes going over it.
Yeah.
The day before the test. No, I'm not putting it on.
Alright,
Because I'm going to take away your time. All right, I'm sorry. Sometimes I have to be sarcastic. I can't help it. All right, now, in your binder, before we do another thing, I would like you to find your worksheets. I would like you to find, started off with the big foldable, the history of the atom. Then you had cathode ray tube. You had Rutherford gold foil experiment. You had the average atomic mass. You had something on alpha, beta, and gamma. You had something on protons, neutrons, and electrons. Did you find all those papers? Make sure, and then that's for here. I'll fix it for you. Yeah.
You take them all out.
You can take them out or put them all together, however you want to do it.
All right.
Nope, that's because that's just for you to study. It wasn't, I did that one, that's just. I was trying to make up for it today. I don't know. And then what do you know about the farm? Okay, but I actually put some what I did in that one, table. So I just, these stuff, I decided not to. Okay, so the first question, everybody has their history of the people. Okay, put that down first. Now, does everybody have cathode ray tube? Okay, put that down second. Does everybody have Rutherford gold foil scattering pictures? Okay, put that down. Then you should have one on, has a picture of a single element that's sulfur on the periodic table. And on the other side, I believe it has things about protons, neutrons, electrons, your shortcut symbolization, that would be next. Then you have average atomic mass. That's just like the paper we just did. It says average atomic mass on it. It's right here. Calculate, oh, it just says calculate atomic mass. You have this one, calculate atomic mass. That's the one like you just did in class as our sample problem. Then you have this paper, where we had to do a bunch of stuff on protons, neutrons, and electrons. On the back of that, does that have review practice problems? So if you need practice on filling out a table, do you have practice problems on the back of that one already? All right, you had one on alpha, beta, and gamma. On the back of it is blank. That's also one that you can use to summarize the 3 subatomic particles if you want to use it to study from. Okay? Not required, but that's something you could use to study, make a study guide off of. All right? This is the one I meant about the protons, neutrons, and electrons, in case you were curious. That was the one I meant by that. I do believe that might be all your papers other than the ones I gave you today. Is that correct? Yeah. Rutherford, yeah, this is the gold foil. Right, and then there should be, okay, well, no, this is, I sort of thinking about how I did it in class. Does it really matter which order it's in? No, because it's not the stuff you need to study. Okay, that's what you need to study. Haley, here, I even made a whole bunch for you. That's what the test is on tomorrow, yes.
Which one's first, second, and third?
It doesn't matter, sweetheart.
Oh, okay,
I just was doing it in the order in which I taught it.
okay.
The reality of it is that what you need to study tonight?
Yes.
Is one got a higher priority than the other?
No.
Well, I would say if I did give one guess, is there are a lot of notes on the foldable. There is a lot of notes on the foldable. But is isotopes also a major part of this? Now, what did I tell you had to know about alpha, beta, and gamma? I told you 2 things you really had to know about those 2, or those 3. Alpha, beta, and gamma, all forms of radiation. Does anybody remember what I told you to make sure you knew from those? Well, that's one thing, if they're harmful or deadly. The charges, whether they're positive, negative, or neutral, their symbol. Make sure you know the symbol for alpha, the symbol for beta, and the symbol for gamma. Absolutely. They're all in my binder. Help yourself. Okay? They're all in my binder. You just take a picture of it. Okay?
Yeah.
All right. Paul, you were out. Paul, you were out from this. You know the picture on radiation, alpha, beta, and gamma? Do you remember the couple things I said you had to know off that piece of paper?
No.
Okay, can you pull that out so you can look at it? It's in that stuff I just gave you. Don't mess it up too much. I put it in the paper clip. All right?
Yeah.
Okay, the symbols. You see the little symbol for alpha, the symbol for beta, and the symbol
Yeah.
for gamma? Okay, you need to know those 3 symbols.
Yeah.
Okay?
Yeah.
All right? You also need to know whether it's positive, neutral, or negative.
Well,
So you need to know the charge.
where's the charge?
It says it right there, there's a column. Did you see, there on the table, it's just say the charge. You see it?
And then I have this, and this.
Okay, and then you need to tell me whether it's like harmful or safe. And remember, we talked about that because alpha and beta were particles. Remember in the picture, you see how they travel in a straight line? You see in the picture, Paul? You see the
Yeah.
picture? You see how alpha and beta are traveling in a straight line?
Yeah.
Do you see how gamma is like a curvy line?
Yeah.
What's that tell you about gamma?
It has.
It's all right.
But because okay, it's
It's
not
okay.
a particle. Really.
Okay, that's right. So alpha and beta are particles. If you're not a particle, if you're not matter, what would you
Array.
You're a ray, which is energy.
Yeah.
Okay, very good. So what's that tell you about who's most dangerous?
Gamma.
Gamma. So does the picture tell you that?
No, but it.
Yeah, it does. Because the picture tell you
Oh.
one's energy and the other 2 are particles.
Oh yeah.
Okay? Now, does it also show you how alpha is bigger than beta?
Oh, yes, it does.
Yes, it does. So the bigger you are, the safer you are.
Mm-hmm.
Okay?
Mm-hmm.
Okay, you were out of the room when I went over that, so I wanted to make sure you got that.
Thank you.
You're welcome. All right, Now, what are you doing with the rest of the class time? The rest of the class time is there for you to study. Now, I did give you one paper comparing Dalton to the modern theory. One side is just a summary, it's the shaded one. The other side was a matching activity. Just because they're named with 1 and 2 and 2, that does not mean they go together. 1 might go with 1, but 2 might go with 4. And they wanted you to see if you can match them up. That's what the activity is on, okay? After you've read the content. By the way, there's only 3 things that happen to make the modern theory different. It was called protons, neutrons, and electrons. Other than that, it's exactly the same. But what did that do? It created an ion.